In this video, we're looking at multiplying that's occurring between two rational expressions. And so the first step, just like the other videos, if you've seen them in my intro, is we're going to factor any quadratic that we can factor. And then after we get its factors, we're going to rewrite this with all the factors, and we're going to start canceling out like sets when we see a numerator and a denominator that match. So let's go ahead and do that right quick. I am going to start by factoring this one right here on top in the numerator. And so this is going to be x squared minus 3x plus 2. And so if I go ahead and write my factors for that, my factors for 2 are just 1 and 2. Now notice it is a negative 3, but it's a positive 2. So I know that both of these have to be negative, because negative 1 times negative 2 gives me positive 2, and negative 1 plus negative 2 gives me negative 3. So I'm going to go ahead and write my factors right quick. So this is x minus 1 and x minus 2. So when I rewrite my problem over here, instead of writing what we had, I'm going to write its factors in the numerator. And so we have x minus 1 and x minus 2. Next, this is just being multiplied. So what I'm going to do is I'm just going to go ahead and draw my line straight across. This is x minus 9. I'm simply going to take that x minus 9 and write it in parentheses. So for x minus 9, we just moved it to the numerator, and I put it in parentheses just to show that all of this is being multiplied. And that kind of eliminates this need for the dot, right? Because a parenthesis means it's being multiplied. And this is, for me, is just a little bit easier to look at. Now I'm going to go ahead and factor the next one. So I'm going to factor this one down here at the bottom, this denominator, and then when we get its factors, we're going to take those values and write them in the denominator right here. So let me go ahead and do that. And so this is x squared minus 81. Now, if you're not good at knowing what numbers multiply to give you that c value, you could always take the square root of that number, which will tell you what two numbers were multiplied to give you that value. In other words, the square root of 81 is 9, so I know that this can be broken up into a 9 and a 9. And because it has no middle term, in other words, it doesn't have the term where it says like some number times x, then I know that one has to be positive and one has to be negative. So my factors for this particular quadratic is going to be x plus 9 and x minus 9. And we're going to go ahead and write those factors right here. So we have x plus 9 and x minus 9. Now we're almost done. We just have one more quadratic to factor, and that's this one right here. And once we factor it, we'll bring its factors down to the denominator right over here underneath the x minus 9. So I'm going to move this up, box it, and do this final one, which is x squared plus 5x plus 6. Now if I work this one out, notice we have 6 as our c value, and so my factors for 6 are 1 and 6 and 2 and 3. Now if I want to get a 5, right, I'm going to go ahead and get this positive 2 and positive 3. And I know they're both positive because the 6 is positive, so 2 times 3 is 6, right? And for those, in case, I know most of you in this class, you've already known what factoring is, but just to show you, 2 times 3 is 6, and then 2 plus 3 is 5, my middle term. So I'm going to write my factors out, and these will be x plus 2 and x plus 3. Now I'm going to take those factors and just write them up underneath the x minus 9, because we just converted this quadratic to its factors. So x plus 2 and x plus 3. At this point, what we want to do is find pairs that are the same and go ahead and cancel them out. And so, for instance, I have right here x plus 9, but in the numerator, I don't have any x plus 9. So that one's going to stay. And then in this one, I have x minus 9. And notice there's an x minus 9 over here. And so those two cancel. And then I have x plus 2, but neither one of these are x plus 2. And then I have this x plus 3 that I left the x out of. And I noticed that we don't have any x plus 3. So what I'm going to do from this point, I'm just going to rewrite this a little bit nicer, leaving the ones off that we canceled, and then we'll find that restriction in just a moment. So let's see, we have x minus 1 and x minus 2. And this is over x plus 9 and x plus 2 and x plus 3. Now this isn't our final answer because we also need to take into account there was a restriction. So I'm going to put comma, x cannot be equal to, and we're going to take this x minus 9 and we're going to set it equal to 0 to get the restriction. So x minus 9 equals 0, and again this is just the one that we canceled. And if we use inverse operations to solve it for x, which is what you should always do, notice it gives me x equals positive 9. So this is my restriction. X can never equal positive 9. So I'm going to put x is not equal to 9. And that's my final answer.